Hello everyone, welcome back to another video. Today we're going to take a look at this question 2 from a past paper. Question 2.1 reads, the table below lists the density of 4 different substances. Now recall from earlier grades that density is equal to mass divided by volume. Okay, and so we have the densities. We have oak wood, aluminium, lead, and water. Now the question says an oak chip and a lead pellet are dropped in water. Which one of the objects will float in water? Now when it comes to density and objects that are floating or sinking, the rule is quite simple. If the density is greater, in this case, if it's greater than water, greater than the density of water that is, then it will sink. If the density is less than the density of water, then it will float. So, for example, if you take oil and water and you pour them into a container, or the same container, the oil will sit above the water, and that's because oil has a lower density than water. So we are comparing an oak chip and a lead pellet. So oak and lead. We can see that oak is 0.8 and lead is 11.35. So oak, the density of oak is less than the density of water. So oak will float on water. Right? That's because, again, the density is less than the density of water. The lead will sink. So the question is, which of the following will float? Oak will float, and it's because the density is less than the density of water. The density of water. Okay, question 2.1.2. A block of aluminium and a block of lead of equal mass is compared. Okay, which block will have a greater volume? So now here we have to just take a look at the formula. So density is equal to mass divided by volume. And from here, we can get a relationship. We can get that density is directly proportional to mass, and density is inversely proportional to volume. Meaning, the greater the mass, the greater the density, or the smaller the volume, the greater the density. So if we have the same mass, so we're not looking at mass, we are looking at, we are comparing volume. So we want to know which block will have the greater volume. The one that's going to have the greater volume is the one that's going to have the smaller density. Because remember, they are opposite. They are inversely proportional. So we want to look for greater volume. We're looking for smaller density. So if we are comparing aluminium and lead, aluminium has a density of 2.7, lead has a density of 11.35. So the answer will be aluminium. Right, so aluminium, because aluminium between the two has the smaller density. Okay, let's move on. Question 2.2. Aluminium reacts with oxygen present in air to form aluminium oxide. Is aluminium oxide a mixture or a pure substance? So aluminium oxide, what is aluminium oxide? Al2O3. Is this a mixture or is it a pure substance? It is a pure substance. Right? Remember, a mixture is something that consists of different compounds. Right? Here we only have aluminium oxide. So it's a pure substance. Mixtures will have aluminium oxide, maybe some other stuff with it, but it's not bonded to it. Okay? So because it's just aluminium oxide on its own, it's a pure substance. 2.2.2, write a balanced chemical equation for the reaction described. So balanced equation, so first we have to write out the equation. Aluminium plus oxygen. Remember, oxygen doesn't exist as O in nature, it exists as O2. So Al plus O2 gives you Al2O3. Now, how do we get Al2O3? So remember, this is going to be a metal plus a non-metal. That means we're going to get an ionic compound. Now, when we're dealing with ionic compounds, we need to look at charges. So, or oxidation numbers if you want. Now, aluminium is in group 3, so it's going to have a charge of 3 plus. Oxygen is in group 6 or 16, so it's going to have a charge or oxidation number of 2 minus. These don't cancel, so we need to switch the numbers here. So that's how we get Al2O3. Next thing we need to do is we need to ensure that it is balanced. Now, to balance it, we look at what's on the right and what's on the left. On the right hand side, I have 2 aluminiums. On the left hand side, I only have 1. So I need to put a 2 here, right? And now when it comes to the oxygen, it looks like on the right I have 3 and on the left I have 2. That's a problem. So what do? Let's get a lowest common multiple. So the lowest common multiple between 3 and 2 is 6. So I can put a 2 in front here to make 6 oxygens, and I can put a 3 in front here to make 6 oxygens. But we have to be careful because by putting this 2 in the front, it's also affecting the number of aluminiums. Now the number of aluminiums is 2 times 2, which is 4. So I just need to make an adjustment here to make that 4. And now it's balanced. Let's move on. Question 2.3. Industrially, solid aluminium oxide is broken down into aluminium and oxygen in 2 steps. Step 1, solid aluminium oxide is heated into a molten or melted form. Step 2, the molten aluminium oxide is converted to aluminium and oxygen. Okay, so it's broken down. 2.3.1 is the process described in step 1 a physical or chemical change. So 2.3.1 is a physical change. Okay, because it's the same aluminium oxide, but it's just in a different form. So before it was Al2O3, but it was a solid, and now it's Al2O3, but it is molten or it's melted, it's a liquid form. So again, it's the same compound, it's just in a different state. 2.3.2 is the reaction occurring in step 2 a synthesis or decomposition? So give a reason. So step number 2 says the molten aluminium oxide is converted to aluminium and oxygen. So Al2O3 is converted to aluminium and oxygen. So basically we're getting 2 products. So whenever you have one thing becoming 2 or more things, that's called a decomposition reaction. Right? And so our reason again, you have one reactant becoming many products. Okay, let's move on. Question 2.4. Use the balanced chemical equation below to show that mass is conserved in a chemical reaction. So that's the law, of course, that we know, the law of conservation of mass. The sum of mass of reactants will equal sum of mass of products. Now, all we have to do is we need to tally up everything. So I'll rewrite the equation just so that it's a bit more clear. So 2NH3 plus H2SO4 gives you NH42SO4. Now, I like to do this left side, right side. So I'll do reactants here. So R for reactants. Now, let's add up the things. So let's add up for this. So that is 2NH3. So I have 2 nitrogens because 2N. So it's going to be 2 times 14. The mass of nitrogen is 14. Then plus hydrogens, I have 2 times 3, which is 6. 6 hydrogens, and the mass of each hydrogen is 1. Then plus, here I have another 2 hydrogens. So 2 times 1 plus sulfur has a mass of 32. And I have 1 sulfur. And then oxygen, I have 4 oxygens, so 4 times 16. Now, if I put that in the calculator, I get an answer of 132 grams per mole. Now, you could put grams per mole, or you could put AMU, atomic mass units. Now, if this is correct, and if we've done it correct, then we should still get the same answer when we do the products. So products, Let's look at the products. How many nitrogens do I have? I have one nitrogen here, but multiplied by 2. So again, 2 times 14, then plus. Let's look at the hydrogens. I have 4 multiplied by 2, I have 8. So 8 times 1. The mass of hydrogen is 1. Plus, I have 1 sulfur with a mass of 32, plus 4 oxygens with a mass of 16. Now you'll notice that it's going to be repeated. The things are going to be repeated. For example, 4 times 16, 4 times 16, you have 32, you have 32, you have 2 times 14, you have 2 times 14, and then here you have 6 times 1 plus 2 times 1 is the same as 8 times 1. So you'll notice that when you're doing it, maybe an indication that you're doing it correctly is that you'll see the numbers are being repeated again. And so again here we'll get 132 grams per mole. Or you could say AMU. You can choose either one. And so we have the answer, the mass on the left is equal to the mass on the right. And so the mass is conserved. And that's the video. Thanks so much for watching. Don't forget to like, share, and subscribe. I'll see you in the next one.